All right, so we'll get started for today. Welcome back, everyone. Hopefully you guys are having a fine Monday night. So today we'll be covering a topic called relational databases, which will be very, very important for many of the apps you end up developing in the future, and we'll shortly discuss why. So before we get started, a few logistical announcements. So do keep in mind, PA2 is due this Wednesday, which is in 2 days. If you ever need help, office hours are always going to be on the EdStem post or the syllabus, so you can always check those out. We have office hours tomorrow and the day after. So if you're ever stuck on anything, feel free to show up. We'll be very happy to help you. Also, a little thing that's a bit irky about our textbook is that you have to refresh it for any of our changes to be shown. So we frequently update the textbook because every semester we just have to do that. And so if you ever think that something on the textbook might be a bit off, please make sure you do refresh it. That way the changes are reflected. Okay, so let's quickly go over the concepts we've covered so far. So we've covered two things so far. We've covered client-server model with routes, and we've covered databases. So the first thing we covered is client-server model. We have a client, which is the phone or the computer, whatever a person is on or using, and we have the server. And so the client makes a request to the server. A server's route is triggered. The term route is interchangeable with endpoint. It's basically a function that the front end hits. And then a data operation, any kind of calculation or business logic is handled within the function. And oftentimes, from the server, you'll be making requests to the database through a SQL command, and data will be returned to you from the database to the server. And then the server returns that response and sends it back to the client in the form of a response. So does this make sense so far? This is what we covered lecture 1 in week 1. So this is a high-level overview of this. The client sends a request to the server, and then the server sends a request to the database through the form of a SQL command. Database returns information to the server through data, and the server returns a response body to the client. So far, we've covered single table databases. What this means is that each of our databases have usually only consisted of one table. So we have a users table, we have a posts table, we have whatever. But let's say we want to have relationships between information that's stored in these tables. So we'll be covering that today. But just as a little recap of single table databases, tables are structured in columns and rows. Columns represent each type of data, and rows represent each entry in the table. You query to the database and make manipulations to the data through SQL. So this is the course overview once again. We have 8 lectures, mandatory lectures, and the first 2 we've finished. We have routes and databases covered. Today we'll be covering relational databases, which again will allow you to have some sort of relationship between your data. So before we get started with today's topic, do any of you have any questions? Okay, cool. Note that today's lecture, it's going to be pretty visual. So I'm going to be writing stuff on the board. So if you have a bit of difficulty seeing the board because it's dark, or seeing the board because you're in the back, then please feel free to come front or let me know so we can make adjustments for you. So, relational databases. What are relational databases and how are they used? So again, it allows relationship between data. So you notice in PA1 you have posts and you have comments associated to specific posts. Another example is Facebook friends, right? How do we know which friends are our friends or which people are friends on Facebook? If you have something like Venmo, which is your PA2 assignment, how do we know which transaction is related to which user? So stuff like this we can represent through multiple tables and by having relationships between them. So again, let's say we have two tables in our database. We have a users table and we have a posts table. So let's say in our users, all we store our names, and in posts, all we store our text. In the users table, we have me and Kate, and in the posts, we have posts that me and Kate would likely post. If you haven't noticed already, I'm a big baseball guy, so that's going to be a bit of the personality of the class. But yeah, so in our users table, we have the ID and we have the data field, the field name. In our post table, we have also ID to uniquely identify different posts. We have the content of the post being text. And you notice here we have something called a user ID. Now, this user ID is going to be very important for us for this entire lecture. The user ID tells us which user made the post. So posts with ID 1, Shohei Ohtani is the coolest person ever, is made by the user with user ID 2, which is me. I love TikTok is made by the user with user ID 1, which is Kate. So right, as you can see here, user ID 2 correlates with the user ID in the users table. So this is called a foreign key. A foreign key is a column in a table that references a row in another table. So the user ID column in our post table references the ID column in our users table. So that's what's called a foreign key. You've noticed that the ID is usually called a primary key. Another name for a foreign key is a secondary key. So that's a little interchangeable term that you should know. So again, the user ID field in the post table associated to the user ID, the ID table, the ID column in the user table. So foreign key columns handle relationships. They are how we make relationships between tables in our database. So there's three relationship types we're going to cover today. It's one-to-one, one-to-many, and many-to-many. So these are going to be very visual, which is what I'm going to be drawing on the board as the lecture goes on. So let's cover them one by one. So what are one-to-one relationships? One-to-one relationships are when one row in a table directly relates with another row in another table, but only exactly one. So let's think of an example, right? Students and net IDs. Each student is ever only going to have one net ID. Therefore, it's a one-to-one relationship because one student can only have one net ID. So I'm actually going to go ahead and write that here, just as a little reminder if you guys forget later in the lecture. So one-to-one table relationships is when one thing in one table has relationship with another thing in another table. Next. So let's see how we display this. So let's say we have a users table, again, with me and Kate in the table. We have IDs 10 and 20 respectively. And in our net IDs table, we have the values KSL67 and SN65, which are our net IDs. It doesn't really matter what the IDs for the net IDs are, for the net ID tables are. But you can see very clearly how the user ID field in the net IDs table directly relates to the ID field in the users table. So if you have 1 and 10 and 20, I'm just going to put my, oops. Okay, and then we have ID. Kate, next. So the SN65 has a user ID of 10, which tells us in the users table, hey, that's Shungo's net ID. All right, next. And same with Kate. So this is how we would represent this in SQL. We have our table users, which looks very familiar to us. We have our ID with integer primary key. We should also have an auto increment there. And the name field, which is a text that's not able to be none. And then we have our netID field, our netID table. So this is the one that's going to be a bit unique, or something we haven't covered yet. We have our ID field, we have our netID field, and then the third field, which defines our relationship, is called user ID, and you have to specify that it's unique. So no two different netIDs can associate to one person, right? So this is why it's a one-to-one relationship. And we have to specify that this field is a foreign key column. So the way we do that is through the keywords foreign key, the name of the column, references, which is another keyword, and then the table's name, and then the column name. So users is the name of the table, and ID is the column that it references. Is this good so far? Cool. So here's how we would insert data into this database. We have insert into users, and we would put my name in it, and then insert into netIDs. We have to specify the netID, and we have to specify the user ID that it's associated to. So that would be me. And since it's the first table or first entry of the table, it'll have an ID of 1. Therefore, the user ID that's being passed in is also 1. The next type of relationship we're covering is one-to-many. So this is when one thing in a table can relate with multiple things in another table. So think baseball teams and players, right? Each baseball player is going to be associated with one team, but one team can have multiple players in it. So that's what a one-to-many relationship is. Next. So here we have a table of team names, right? So we have Los Angeles Angels with the ID 10 and New York Yankees with the ID 20. In the players table, we have multiple players, all of which are in one of these teams, and the team ID telling us, hey, which team is this player on? One thing to note is that, we'll show you in a sec, but the team ID doesn't actually have the unique constraint that we had in our one-to-one table, a one-to-one relationship. And the reason why is because we can have multiple players be associated to a singular team. So you'll see in a sec that this team ID field will not actually have the unique constraint. So okay, I'm not going to write the table because it takes a while, but yeah, next. So let's say we want to see what team each player is associated to. So say we query Shohei Ohtani, and we see that his team ID is 10. Then we'll go to the teams table and say, hey, which team is ID 10? And then it tells us Los Angeles Angels. Likewise, we can do the opposite, right? We can go to the teams table and see, hey, Los Angeles Angels has the ID 10. So which players have the ID 10? Well, it's Shohei and Mike Trout. So yeah, that's how you have a one-to-many relationship. And same with New York Yankees. So this is very similar to how we queried the one-to-one relationship, where we can insert in a very similar format. We insert the name, and we insert the ID of the team that they're associated to. And one thing you can do that's pretty cool with one-to-one or one-to-many is you can select all from players where team ID equals 20. And what this does is it gives us all the players with team ID 20, which is all the players in the New York Yankees team. Next. So here's how we create the two different tables. We have teams, which hopefully looks very familiar to you guys. We have the ID and the team name, and that's it. But we also have the players table. So this has the ID, it has the name. It has a team ID, which is very similar to what we had earlier, being the user ID. The only thing that's different is instead of having integer unique, it doesn't have to be unique, right? Because multiple players can be associated to multiple teams. So the only thing we specify is integer, not null. And then same syntax with the foreign key thing. Does it make sense? Cool. So the last thing we'll cover, and probably the most complex thing that we'll cover today, is many-to-many relationships. So this is when many things in a table can be associated to many things in another table. So think student and courses, right? Each student can be associated to, well, each student can be enrolled in multiple courses, and each course can have multiple students in them. So how do we define this type of relationship in SQL? Well, let's find out. So there's 3 ways of doing this. More than 3, but 3 general ways of doing it, and 2 of them are not that great, and the last one is what we're going for. But we'll cover the first 2, and the reason why it's not that great. So the first option we have is to store multiple columns, or is to have multiple columns per foreign key reference we want. So what this means is, let's say we're trying to represent students and courses, and we have a field course 1, course 2, course 3, right? And we store each of their courses that they're in. But obviously this raises the problem of, well, what happens if a student wants to take more than 3 courses, right? Or are we just going to have course 4, course 5, course 6, and just have it infinitely go on? Like, no. So let's see an example of that. So let's say Kate and I are taking very standard freshman classes, and we have Gonzalo, our backend lead, taking like 6, 7 classes, and we're like, what the heck? What is going to have, like, fill in these slots? Well, we're not taking any more than 3 classes, so we'll probably have them know. But you can start seeing how this already becomes very, very space inefficient, right? So if you have like a freshman taking like 10 courses for whatever reason, and everyone else in the university is taking like 4 or 5 courses, for each user, we're going to have 5 null spaces. That's very space inefficient, right? So like, what if Rahi's taking like 1 course? Well, then 4 of his fields are null. So obviously, this is not a great way of implementing it. So let's discuss the next way that we can think of. So the next way we can think of implementing many-to-many is by storing a list of users or a list of IDs, right, in these columns. So let's examine this, right? We have me taking 1110 and 1998, and we have Kate taking 1110. In the courses, we have 1110 and we have 1998, and the students enrolled in each of them. So in 1110, we have me and Kate, right, 1 and 2. And in 1998, we have just me. And in the students table, we have a very similar representation of how the courses are stored. Right, so the courses field in the student table corresponds to the ID field in the course table. And vice versa, right? So the student field in the course table represents the ID field in the students table. Now let's add a student. Let's add Gonzalo. And he's taking 1110 and 1998. Well, what happens? So we want to insert him into these 2 entries of the courses table, right? Now, since we want this representation to be consistent, we have to add 3 to both of these lists. Make sense? Right, because Gonzalo has ID 3 and he's taking these 3 courses, therefore we have to add him to this list. The reason why this isn't great is because let's say we have 1110, a core class like 1110 where like 300, 400 students are enrolled. This list starts to become really, really, really long. And if we want to index, let's say I want to see if student with ID 100 is taking CS 1110. Then we'd have to go through 100 elements, if there's, say, like 1 through 100, all stored in this list. So basically, like, it's going to be very time inefficient with this, because lists obviously take a while to search through. So what's our solution? So you can see here, these 2 are the fields that define our relationship. We have the students table with our courses field, and we have the course table with our students field. We can just mash them together into what's called a joint table. So this is the solution we're going for. The joint table has the 2 fields that we had earlier in our student and course table, except we're not storing them as lists. We're just storing them as individual entries into the table. And this makes it very, very efficient, right? So if you want to look at everyone who's taking 1110, we can just scan through this entire table and see which fields or which rows have course ID of 1110. So let's examine that. Let's say I wanted to know what courses I'm taking. Well, then I'll just go to the join table and see all the rows with student ID of 1. And we can see from over here that it's 1110 and 1998. We'll then go to the courses table, and we can see all the information associated to each of the courses. In this case, it's only the title, but we can have more information on it. And this makes it so that you can just go from one table to the middle table to the last very easily. Let's examine the reverse. Who's taking 1110, right? Then we go to the join or association table and look through each of them and see which students have the course ID of 1110. We'll go back to the students table and see that it's me and Kate taking 1110. Now, if Kate, say, enrolls in CS 1998, that just becomes a new entry into our table. The reason why, again, this is efficient is because for each of these fields, we only store one element in each of the rows. And this ensures that we're not going to have to loop through every single item in a list to find what we want to be finding. So in SQL, what does this look like? We have our students table. We have our courses table. This looks very familiar to us. This is actually exactly the same as PA2. We don't actually have foreign key columns in either of these tables. Here's the join table, right? In a depiction earlier, if you don't recall it, actually I'll just scroll back to it real quick. You can see that neither of our tables have the foreign key column. We just have a third table called the join or association table. So that's the creation of this right here. Oops. We have our ID. We have our courses ID field. We have our student ID field. And each of them reference their respective table and the field within that table. So we've covered one-to-one, we've covered one-to-many, and we've covered many-to-many. Any questions before we move on to demo? Okay, cool.
Okay, valid. Basically today we're just going to show, we're first going to show like how to model basic relationships in SQLite, and then we'll move to like the VS Code. So first, you should have installed SQLite 3 last time from demo 2. So I'm just going to open terminal. And then to activate SQLite 3, we're just going to do SQL. Wait, let me make this bigger. Sorry. Is that a good size for everyone? Where is it? Okay, cool. So to activate it, we just want to type in SQLite 3, and then you should be met with this like command line interface for SQLite 3. Cool. So this should have been downloaded last time, but if you have any issues, feel free to raise your hand. But what we're first going to do is just create a table for users and NAT IDs, and we're going to create the one-to-one relationship that we talked about in lecture. So if you don't remember, to create a table, we basically want to do create table, and then we're just going to call it users. And then in users, we just want ID, which is the integer primary key, and we're going to auto increment it. And then we also want name, and we don't want this to be null, which is the text. Cool. So this is how you create a table, and then you can check what tables you've made by just doing dot tables. So you can see here that we made a users table. Does that make sense to everyone? Cool. So I'm just going to create another one for NAT IDs. And then we want the NAT IDs table to reference the users table so that we can create a relationship between the users and the NAT IDs. And then because this is a one-to-one, your user ID should be unique. So to do this, we're just going to write user ID is integer. And then to represent that it's unique, we do the keyword unique. And then another comma. And then to establish that foreign key, which basically is that column in the users table right here, we want to write user ID, and this references users table and then the field ID. And then we're just going to end this. And then we've created our net IDs table. So I'm just going to double check that it's actually been created by doing dot tables. And you can see the net IDs table is here. Does that sort of make sense to everyone? This is just a quick review from last time with the addition of the foreign key column for a one-to-one relationship. And the unique is just to establish the only one name can be associated with one net ID, and one net ID can only be associated with one user. Cool, so I'm just going to insert some values into the table now. So I'm going to insert myself into users. Oh, wait. I forgot to establish the column. Wait. So basically, I just inserted myself into the users table. And to check that, I can just do select asterisk, which is everything from. I'm a really bad typer. So you can see that I've successfully added myself to the users table. And then I'm just going to add Shingo in the users table as well. So I'm just going to do the same thing, insert into users, column name, and values. Yeah, so I'm just going to double check that I added everything. And you can see now I have two values, key and Shingo in users. Does that sort of make sense to everyone, how I inserted the table, values into the table? Okay, cool. So now I'm just going to add stuff into net ID. And in net ID, you see we have this user ID. So we have to insert the user ID when we insert stuff into the net IDs table, which will make more sense once I actually do it. So insert into net IDs, we want to insert the actual net ID and the user ID. And then the values. So I'm just going to insert my net ID in, which is KSL67. And then my user ID, which you can see up here, is 1. So 1. And then now we're going to check if it's successfully been added into the net IDs. So you can see this is our net IDs table, and this is the ID for the net IDs table, and then this is the actual net ID that I added, and this is the foreign key that references the user ID. Does that kind of make sense? So for user ID, I have net ID KSL67. Cool. So I'm going to do the same thing again. Here's Shingo. And then he's user ID 2. And then we're just going to check everything's been added. And cool. Now I have two things in my net IDs table. And then now, let's say I'm like feeling quirky or something, and I want to change my net ID to Gonzalo's net ID, which is GG387. So I'm just going to insert into net IDs, net ID, user ID. And then I'm going to add another net ID for me, which is GG387 for user 1, which is me. And then you can see that I get an error because when I defined my net IDs table up here, I said the integer had to be unique. And because I'm inserting another value into net IDs, for user ID 1, I failed the constraint that every row had a unique user ID. So this is a one-to-one relationship. Only one net ID can be associated with one user and vice versa. So yeah, if I wanted to change this, I would have to do an update command instead of an insert. Does that kind of make sense? Cool. Okay, so this is a one-to-one relationship. So now we're going to do a one-to-many. So I'm just going to skip a couple lines here. And let's say I'm like making a social media app for like Cornell students. And so I want to have posts now. So posts is like a one-to-many because each user can have multiple posts. So I'm going to first create a table for posts. And then let's say we're just going to do description, which is text, not null. And then we want to have this be associated with the user. So this is going to be an integer, and we don't want it to be null. And then we're going to establish that relationship with the users table. So I'm going to do foreign key. And then the user ID is going to reference the users table and the ID field. So now when I check all my tables, you can see I have 3 tables and a new post one has been created. Cool. And then notice how, because this is a one-to-many, we can have multiple user IDs be associated with like, multiple posts be associated with a user ID. So this does not have to be unique. It just has to not be null. And then, yeah, I'm going to make a post now. So let's say I made the post. And I'm going to say, I love Max flatbreads. And then my user ID is 1. And then I'm going to select everything I have from post. And you can see that, again, post ID 1 with the description, I love Max flatbreads, is associated with user ID 1. Does that kind of make sense how I did that? Cool. So I'm going to do another insert statement. So let's say Shingo wanted to post something. And then, let's say he said, Kate is the better instructor, because I am. And he is user ID 2. And then if I select all from posts, you can see that now I have 2 posts associated with 2 different users. And I can even like, let's say I wanted to make another post like, really nervous for my prelim tomorrow. And then I'm user ID 1. You can see I did not get an error, and I have multiple, oh wait, that's users, sorry. You can see I have multiple posts associated with user ID 1. So they're not, the unique constraint for the users and not IDs does not apply for the one-to-many relationship because we established that the user ID just has to be not null and not unique. Does that kind of make sense? Okay, cool. So yeah, this is a one-to-many, so I can keep on adding rows for my posts associated with the different users. And then one thing I wanted to show was, so we use SQLite in this class, which is just like one interface for implementing SQL. And so the thing about SQLite is that it's not very strict when it comes to like what kind of data you want to insert into your table. So let's say I wanted to insert into posts, and then description, user ID. And then let's say someone said full summer is such a block. And then this is user 1000. So you can see that no error message was returned, even though a user with an ID 1000 doesn't exist. We only have, or you can see up here, we only have 2 users. So SQLite doesn't really enforce what type of data you insert into each column, which kind of contradicts what we said last class, that this is why databases are good. But this is only with SQLite. With other types of database interfaces like Postgres, the data type is actually enforced. So yeah, just don't insert anything wacky into SQLite, but just wanted to show you all that. And then last thing is you can have like different functions for each column. So for example, I can count how many posts are associated with user ID 1 or user ID 2. So I can do select count from posts where user ID equals 1. So I want to see how many posts I have, and I have 2 posts. So I can do the same thing for Shungo. So he has 1 post. And then because the data type wasn't enforced by SQLite for user ID 1000, you can see user ID 1000 also has 1 post. But if I did like count for user ID 10, which did not have any posts, you can see it's 0. So I can verify this by just selecting everything from posts. Everything is correct. So count is just sort of like another function. You just have count and you insert whatever you want to count, and then from the table. And then the where is something we learned last class, which is just sort of like a conditional statement. Does that kind of make sense? Good question.
So when you're creating the table, what's the point of the foreign key reference? Like, it doesn't enforce anything.
Yeah, so the foreign key references still establishes that relationship to the other table. So for example, here, we established that this user ID is associated with users. So later when we select like values from the users, so I can do like select users dot name, which is only a field in the users table from users. I can do that because it's sort of related to the post. Does that kind of make sense? So I can get stuff from other tables that I have like a foreign key associated with using this column, but it just doesn't enforce like if something exists in that table or not. Yeah, does that kind of make sense why the foreign key is still relevant? Because we still want that relationship to happen when we're like relating users and posts and stuff like that. Cool. So last type of relationship is the many-to-many. Does anyone have any questions about the one-to-many or the one-to-one? Okay, cool. So I'm going to lastly implement this hashtags feature in my social media database. So this is going to be a many-to-many relationship because many posts can be associated with like many hashtags, and many hashtags can be associated with many posts. So it's sort of like a mutual many relationship thing. So I'm going to create a table called hashtags. And then the values are the ID for the hashtag table, which is an integer primary key. And I'm going to auto increment it. And then I'm going to do post ID. Oh, wait, just kidding. So for the hashtags, I just want the hashtag name, my bad. So we're just going to do hashtags, and then the hashtag is just going to have a name, which is a text. And then we're just going to end that. So when I do .tables, you can see I have another table right here called hashtags. And because this is a many-to-many, I'm going to create that sort of association table that associates the hashtags and the post together, which is basically what the students in courses join table did in lecture. So this is just going to be another table, and I'm just going to call this like your feed or something when you scroll through a hashtag. And then your feed is also going to have an ID. And then now we're going to sort of have those columns that associate the posts and the hashtags together. So I'm going to have a column called post ID, and this is going to be an integer that's not null. And I'm going to have a hashtag ID, which is also an integer that's not null. And then I'm going to just do like 2 foreign key references because they are foreign keys. So I'm going to do foreign key, post ID, references, post, and then ID. And then I'm going to do another one, which is foreign key, hashtag ID, references. And you can see when I do dot tables, I have my association table created. So we're just doing the same thing we've been doing for all the other tables, but now the only thing in this association table is just the IDs from the different tables. Does that kind of make sense? Cool. So I'm just going to insert some hashtags in. So let's say I have a hashtag for food, and then we're going to have a hashtag for pool. Insert hashtag. And then like code or something. Cool. So now if I select everything I have from hashtags, you can see I have all the hashtags. And then I'm going to insert that relationship between the posts and the hashtags now. So insert into feed, and we want to insert a post ID and a hashtag ID. And then let's say for these posts, I want to have hashtag food for this first post right here. So I can do values and then 1, 1. And then when we do select from feed, you can see this is sort of like not very readable, but this is like the feed ID 1, and it's associated with post ID 1, and this is associated with hashtag ID 1. So this is just sort of a bad example because all of them are 1. But if I insert into feeds like post ID, hashtag ID, and let's say I wanted to associate Kate is a better course instructor for hashtag ID 2, where let's do hashtag ID 3, which is code. Let's do select from feed. And then you can see I have like another sort of column or another sort of row for all the joined thing together. So I know this is not very readable, but I can do like a really fancy like join statement that sort of makes this more readable. And this is sort of what I mentioned earlier as why the foreign key is important, because it sort of establishes that relationship with each other. So let's say I wanted to select the users, or let's say I just wanted to select the post description and then the hashtag's name from the feed. And I'll talk about the inner join in a minute. Post ID, inner join on hashtags. Hashtag ID. I'm going to end this. So you can see this is much more readable, and this is basically everything in here, but I'm taking the posts in the description, which is I love Max flatbread with the hashtag, which is food. And the same thing with Kate is a better course instructor with code. And then the inner join just basically takes all the instances from feed and post where the feed post ID is equal to the post ID. And then we do the same thing with hashtags where we take everything in the feed hashtag column and we query everything from the hashtags ID that matches with it. Does that kind of make sense? So just like a basically like loops through the whole table and it finds where the post ID is equal to the feeds like post ID in here. And then the same thing for hashtags. Does that kind of make sense? So it's sort of a very big statement, but that's sort of what it does. And it makes this more readable. And the reason we don't do this directly is because if we do this multiple times, it's going to be really not legible. And this is just easier on the eye, but it's sort of like referencing objects and their attributes in Java or Python. So yeah, does that kind of make sense? This whole SQL thing and how we have sort of created all the relationships that we talked about in lecture. Okay, cool. So next time we're just going to implement this in like our actual server. But yeah, we're just gonna move on to the Kahoot now. What?